Hello, wonderful students. We are going to go over some problems that will help us for the upcoming assessment. So we're going to start off with just some notes. So remember, open versus closed. Open would look like, I like to use this trick, an open dot right there. Versus closed, the dots have to be filled in, as you can see right there. So open versus closed. What's the difference? When is it open? When is it closed? You know this, right? So open circles are, for example, greater than. I'll write down greater than. And notice we have an open circle facing the right. What do you notice about the symbol versus the arrow, right? They're facing the same way, which is really cool. So typically we would say x is greater than 7, for example. So the number 7 on a number line is going to be right there. Another example could be x is less than 5. So we'd have an open circle on the number 5. And it would only include numbers that are less than that. So is 5 less than 5? No, that's why there's a hole there. There's an open circle because 5 is not a solution. So we can say for this one, they are not including 7. And this one is not including 5. All right, now closed could be, for example, x is greater than or equal to 7. We'd have to include a closed dot at 7. Or we can have x is less than or equal to 5. Just examples that we can remember to include. Closed dots. Do these include the number 5? For example, this one includes the number 5. Does this include the number 7? Yes, because it could equal 7 as well. That's why you're going to see a little bit of an equal sign right there. It means that it includes. So just to write it down, we have greater than or equal to. Or we have less than or equal to. So if it could equal it, then that's why we need to include the dot on that number. So just a little bit of another note is, remember for open circles or greater than, it could mean that it has to have a dotted line. That's for 2 variables. And if it's closed, then it would be a solid line. Just like this is open, and this one's closed. This would not be a solution versus this one would be a solution. And that's for 2 variable. Okay, so now some examples. X is greater than or equal to 1.5. We can put that on a number line. So it's good to include the number 0. Find 1, find 2 perhaps. And draw an open or closed circle. Okay, so it's going to be open. No, it's going to be closed. Why is it closed? Because it's got the equal sign. Something to keep in mind. Go ahead and put a dot on 1.5 and make sure that the arrow is facing the same direction, right? Isn't that crazy? The symbol points to the right if it's greater. The symbol points to the left if it's less than. These symbols tend to match the symbols right there. The inequality symbols match the arrow, just like this. The inequality symbol should match the arrow if x is on the left side like that. So here we go. That's the first one done. The second one is going to have 2 numbers. So let's find the number -2. Write 0, write 7, just in general where those numbers would be. For the -2, it could be equal to -2, so I'm going to write the closed dot. And for the 7, it should include an open circle because there's no equal sign there. It's less than 7. So it should be both less than 7, and it should also be greater than, you see, greater than -2. So all of our solutions lie in between these two. I'm going to go ahead and say between. Just like x is between the two numbers, any number for x should be between the numbers -2 and 7, but they could include -2. Now for the next one, letter C, I chose an or. Or means either. So I like to think about this one as thumbs in. Most of the time it's going to be thumbs in, like this. Thumbs in, they face each other. Versus or, it's most likely going to be thumbs out. So they're going to be facing opposite directions. So let's do that. -2, 0, 4. You could include the numbers there if you want to. Now, is it open or closed? Okay, so it's going to be open since it's just 4. Let's put an open dot there. It's greater than 4. But it also has to be or less than -2. So the number -2 is also closed. We'll put the arrow facing the left. So we'll call that, just as a trick, thumbs out. They're facing outward directions. So keep in mind, is 0 a solution? Nope, it's not there. Is -1000 a solution? Yes, because it's over here. Is 5 a solution? Yes. And here's a question. Is 4 a solution? The number 4. Check it out. Is that an open or closed circle? The open circle indicates it has to be greater than 4. It cannot be equal to 4. So is 4 a solution? You can say no, it is not. All right, now moving on to some solving questions. Let's solve some inequalities. Remember, the only rule that is very, very important is, I'll write it here, if you multiply or divide by a negative number, what must you do? You must switch the sign. Or test your boundaries. For this first one, we're going to go ahead and add 3. Giving us 2x is less than 5. Divide by 2, and that gives us x is less than 5 divided by 2. What is 5 divided by 2?
The answer is 2.5.
2.5. So we're going to graph that on a number line. We're going to put 0, we're going to put 1, we're going to put 2 and 3. We're going to include an open circle facing it to the left, since it's less than that. And that would be our final answer, along with this one, 2.5. Okay. The next problem is going to be letter B. We're going to go ahead and subtract 7 to get x by itself. That gives us -2x is less than 5 minus 7. 5 minus 7 is -2. Good. Next up, we're going to divide by -2. That gives us, wow, we just followed a rule that requires us to switch the sign. So we're going to go ahead and switch the symbol. What that means is, instead of it being less than or equal to, it's got to be, what's the opposite of less than or equal to? Right? We're going to go ahead and change that to greater than or equal to, switching the signs. Now, -2 divided by -2 is +1. So we're going to go ahead and graph that on a number line. Here's 0, here's 1, open or close circle. Good. Equals requires us to fill in the symbol, and it's going to be pointing us to the right direction. Okay. Now let's test. We could test a number, right? If you plugged in the number 0, if you tested the number 0, do you think 0 is going to be a solution? Check it out. Try it out. Plug in the number 0. Let's test 0. So in our original inequality, negative 2x plus 7 is less than or equal to 5. If we plug in 0 into that equation, or inequality, sorry, would it be true? What happens if we put 0 for x? What do we get? This will be 0. This will be 7. And 7 is less than 5. Is 7 less than or equal to 5? The answer is no. So 0 is not a solution. Remember, you can test it by looking at it visually. Did you switch the signs? If you didn't switch the signs, you would visually see that it's wrong. But you can also test numbers by substituting them into your equation. What is the easiest number to test? 0. I'll write that down. The easiest number to test is 0. Plug it in, and you're going to get your answer really quick. So that is a great way to tell that you did this correctly, or shaded it correctly in the right direction, in the correct direction. Okay, next up is going to be an absolute value question. Remember, for absolute value questions, it's important to switch it into two answers. It's going to be the positive version of the answer, or it's going to be the opposite, which I'm going to say is very important to not mess this up. Not only are you going to switch the number 13 to be negative 13, you're also going to switch the symbol. So it's not going to be greater than anymore. It's got to be less than. So 2x plus 5 is less than or equal to negative 13. Do you agree that these are opposites, right? The symbols have switched. Why do we do this? You know that we do this because the absolute value has two answers. The positive version of whatever goes in here, and also the negative version of our solutions. So we need to determine both the positive value and the negative. And when we switch the negative to the other side, that requires us to switch the symbol. So remember to always switch the symbol. So solving, we're going to go ahead and get two solutions. Let's graph them. After we solve them, of course. So that gets us, after subtracting 5, we get 2x is greater than or equal to 13 minus 5. Let's solve the second one. The steps for the second one is very similar. Do the same thing on the right side. We have negative 13 minus 5. That'd be negative 18. And solving, we're going to go ahead and divide by 2 to both sides. And it gives us our first solution. X is greater than or equal to 4. And our second solution is x is less than or equal to negative 9. So let's graph this on a number line. Let's put negative 9, let's put 0, and let's put 4. You can put the tick marks in between if you want to. I'm going to go ahead and ask, is it an open or closed circle for the first solution? It's going to be a closed circle. Good. And for the second one, is it going to be open or closed? We have negative 9 is equal to, so it's part of it. And now let's go ahead and graph this. It says that x should be less than negative 9. And it should be also greater than 4. So you can consider this sort of a thumbs out situation, which is very common for absolute values. Okay, letter D. Letter D, we're going to go ahead and solve this by distribution and algebra. So after distributing the negative 5, we get 3x minus 5x. What's negative 5 times negative 2? Right. Negative 5 times negative 2 is, you're right, positive 10, giving us this new equation, or inequality. Let's combine the two like terms. 3x minus 5x. And let's solve. We're going to go ahead and subtract 1. Carefully solve that, by the way. 4 minus 10 is negative 6. Now we are going to divide by negative 2. What happens when you divide by a negative number with inequalities? What does it say? If you multiply or divide by a negative number, you must switch the sign. So we're going to go ahead and switch this symbol to not greater than, but it's going to now be less than. And it's going to be less than positive 3. Negative 6 divided by negative 2 is positive 3, putting us at our final answer of x is less than 3. Open or closed circle? It's going to be open, right? So we're going to go ahead and put an open circle on the 3 and face it to the left since it's less than 3. And that's our answers, our solutions. Now, finishing this up right here, we have for inequalities is this statement true or false? Is the absolute value of negative 71 greater than or equal to 71? What do you think? Tell the person next to you. Is it true or is it false? Here's the answer. 71 is the absolute value of 71. Now, is 71 greater than or equal to 71? The answer is true. Right? Because 71 is equal to 71. That is true. Next up, is negative 13 greater than negative 12? The answer is false. Negative 13 is smaller number than negative 12. And here we have two absolute value questions. Is the absolute value of negative 5 greater than the absolute value of negative 7? What do you think? Tell the person next to you. Okay, so we get 5 is greater than 7. Turn these numbers positive. And what happens? 5 is greater than 7. Is that true or is it false? The answer is most certainly false. Okay, that wraps up inequalities. What we're going to do now is we're going to review a couple of standards that we just did on our last test. So our first step is to review standard 8b, and then we'll review the test standard 8c. And let's begin with 8b. Let's just begin with 8b. Okay, so here was question 8b number 1. Mr. Chase began investing into a foundation that promised to double his money every year. He cautiously only invested $150 at first and began to see his money double each year. Let's write an equation. So it says that his starting value is $150 and he begins to double his money each year. So we can say y equals 150 times 2 to the power of x, or you could say to the power of t for time, whatever you prefer. how much will he make, or how much will he have in his account after 7 years? So we will go ahead and multiply or insert the number 7 into our equation, giving us an answer of, well, let's see, we can put this into our calculator here. 150 times 2 to the power of button right there, the caret button, to the power of 7, giving us an answer of $19,200. So answer for number 1, letter B, is $19,200, assuming that he started with 150, doubling his money each year. Now, just to double check, we could put this number into the graphing calculator or this equation. So if we put in our equation by pressing y equals, clearing anything that's there, and typing this equation, we can actually see our entire table. So we're going to plug in the numbers 150 times 2 to the power of x. Here's our x button right there, the x, t, theta, n button. It'll give us the letter x. So if I press graph, it will show me a small version of our graph. This one might not be in the best mode right now, but guess what? The graph doesn't really visually tell us much. Okay. What we would really like to see is the table. So I'm going to go ahead and zoom into where it says table on your calculators. So I want to access that button. How do I access that blue button? Right, press second table, and it gives me the table of values. So what's crazy is we know that after 1 year, he's going to have 300. He's going to double it, get 600, double it, get 1200. Keep on doubling it, and let's see how far, because we can go down just by doing the down button. How much will he have after 7 years? There it is, right there. 19,200. How much will he have after 30 years? I think it'll be so much money that we can't even comprehend, because doubling is a really, really good amount of money to have. If you can double your money every year, wow. Hats off to you. Let's go to number 2. Graph the following exponential function and complete the following table. So I'm going to say that a is 4. Our starting value is 4. So I'm going to tie that in with, see, this marker's not working too well, huh? I'm going to tie that number 4 into our starting value, 0,4. And 1.25, that's our b value, the multiplier. So if I multiply by 1.25, we'll get our next numbers. So calculator, 4 times 1.25. That gives us 5. Now if we keep multiplying by 1.25, what would be the next number? 5 times 1.25. That gives us 6.25. Let's multiply that by 1.25. 7.8125. And let's multiply that by 1.25. That gives us 9.766 approximately, just writing a few decimal places. Now, how do we go back and find out the negative, right there, the negative? So what we would need to do is the opposite of going down by multiplying. We would need to, sorry, that was showing off the camera there. We would need to go backwards. We need to do some inverse operations. The opposite of multiplying by 1.25. Yeah, we're going to have to divide by 1.25. That gives us, if we do 4 divided by 1.25, that gives us 3.2. So graphing it, we're going to get negative 1, 3.2, 0, 4, 1, 5, 2, 6.25, just about there, 3 comma 7.8, which is just about right there. And 4 comma 9.76. Notice how these numbers are getting pretty big pretty quickly. 9.7 is about there. So we can give it a quick sketch that these numbers are going to increase pretty rapidly. Okay, next up is Sailor Twift. Number 3, Sailor Twift has stopped doing her homework and noticed her test scores have been decreasing by 15% each test. That doesn't sound too good. So we're going to have to decide how to come up with an equation. If she started with 72 points on her first, or I should say, I'm going to go ahead and say initial start value. If 72 was her first test, we'll write down y equals 72. But what is a decrease of 15%? Remember, everyone starts off their day at 100%. For example, my battery right now is not at 100%, but it's close to it. I started my day with 100%. What happens if I decreased by 15%? What would that be? Right? What is 100 minus 15?
That would be 85.
So 85%. Giving us our multiplier 0.85. This step is very important because if we said 0.15, it's incorrect. It's only a decrease of 15%, so that would be our multiplier. So how many points will she score on her third test? We're going to assume that this is going to be 3 tests after the first one. So we're going to put in the number 3. Maybe it's a 2 because it does say her first test was 72, so 2 tests later might be to the second power. But we're going to leave it as 3 just for the assumption. So that gives us 72 times 0.85 to the power of 3, which is, it says approximately 44.2 points. Okay, next up is asking us to complete the graph or complete the table based on the graph here. So we're going to go ahead and complete the table with numbers that are given to us. We're given 6, we're given 1 comma 9, we're given 2 comma 13.5. Now what is the pattern if it's exponential? Right, we're going to need to figure out our b value. What is the multiplier? Just like we had the multiplier here, what's the multiplier over here? So the trick is to do 9 divided by 6. We get 1.5. We can confirm that as well by doing 13.5 divided by 9. Just dividing the previous number. It gives us the multiplier every time. So 13.5 divided by 9 is also 1.5. So that means the multiplier is definitely 1.5. We're going to need to keep multiplying by 1.5, multiply by 1.5. So let's do that. 13.5 times 1.5. That's 20.25, which is a number that's not going to show up on our graph, right? The numbers won't fit. But that table's pretty important. Now, we need to multiply 20.25 times 1.5, giving us this answer here, 30.375. And now we also need to figure out that starting value. How do we go backwards? Instead of multiplying by 1.5, you got it. We got to divide by 1.5. So that's going to be 6 divided by 1.5, which is, oh, I think I typed that wrong. There we go. So I need to do not multiplication but division. 6 divided by 1.5 is 4. So if you really wanted to come up with the equation of this, you could say the starting value is 6, the multiplier was 1.5. But this question only asked us to fill out the table, so this work would be complete. Okay, next up we do need to review standard 8C. 8C is called curve fitting, so let's review that right now. To do curve fitting, you probably are going to need to know how to do cube roots, fifth roots, fourth roots, things like that. So we're going to need to find that in our calculator, and every calculator can be different. Some calculators can be different, so please prepare to find out how do you do these roots. Cube root, fifth root, fourth root, things like that. So solving number 1, we need to isolate b. We need to get b by itself. What we'll need to do is divide by 15, giving us 1215 divided by 15 is 81. 81 equals b to the 4th power. What's the opposite of the 4th power? Yeah, what it's called is the 4th root. So we'll need to take the 4th root of 81. So we're going to go ahead and say b is the 4th root of 81, but let's figure out what that is. So what number times itself 4 times is 81? Here's the answer. The answer is 3. 3 times 3 times 3 times 3 is equal to 81. But instead of just guessing, we're going to go ahead and input this into our calculator. So I will press the math button, go to option, well, this 4th option is the cube root. The 5th option is any root. So let's see what happens if we press option 5. So again, how do we get here? We went math button, and option 5. Let's see what happens if I press that. What this does is it tells me whatever was in my calculator prior, I'm using that number, so I need to change that to a 4. So typing the number 4 gives us a 4th root. 4th root of 81, press enter, it equals 3. Perfectly done. Okay, number 2, write the exponential equation of a curve through the coordinates 1, 14, and also 3, 686. By the way, shout out to Squishy, shout out to Drake, also Natalie and Rolo. Some requests from students there. Okay, so let's input these numbers here. We'll get 1, 14, 3, 686. Using a table might really help us figure out our answer. So one option is to guess and check. What number do you think we'd multiply by not only once, but twice? Right, multiply by something twice to get to 686. So guess and check. Let's see, 14 times 2 times 2. Now that number is too small, so it can't be times 2. Is it 14 times 3? Times 3? It's still too small. Is it 14 times 5? Times 5? Too small. Is it 14 times 6? Times 6? Still too small. My goodness, wow. Is it 14 times 7? Times 7. That's where it's going to be. So we could figure it out by guessing and checking. Another way to do this is, look, how many steps did it take to get there? It's going to take 2 steps, right? So we're going to say 686 equals 14 b to the 2nd power. Just like we had here, this is going to be 4 steps. This is going to be 2 steps. 14 times what? Twice, 2 steps, is going to equal 686. So we can solve this really quickly by, again, doing the same steps we did here. Divide by 14. 686 divided by 14 is 49. And what's the opposite of square? Right, square root. So we can go ahead and take the square root of 49. Well, I can press the square root button right there. The square root button is right there. Square root of 49 equals 7. So that gives us the multiplier of 7, just like we figured out before. Let's say you can guess and check. Otherwise, you can solve for the multiplier, b, using this sort of trick. So let's fill in the missing numbers. The multiplier is 7, which you could guess. It's going to be 14 times 7, 98. And you can fill out the rest of the table if you want to. You can multiply by 7 as well here. And that gives us 4802. But this number is not the number that matters. We really don't need these numbers. What we really need is the starting value. So how do we work backwards to get the starting value, right? So the really important piece is the starting value and the multiplier. So to divide by 7 would give us the multiplier. That gives us the starting value of 2. So let's write the equation for this. The starting value, which is our A, is 2. The multiplier is 7, which is our B, and that's to the power of x. Done. So ask yourself, would you rather guess and check, or would you rather use an equation similar to this? It's up to you. Okay, number 3. This is a weird one. The starting value happens to be the number 1. It's right there. And the multiplier looks like we're going down by 0.5 here. So I'll say 1 comma 0.5 versus 0 comma 1. How do we get from 1 to 0.5? Right. That's going to be multiplying by 0.5. So final answer here is either you don't really need the 1 there because it's just multiplying by 1. The answer is going to be either 0.5 to the power of x, or you can also say 1/2 to the power of x. Either of those answers is totally fine. This is a little tricky because the graph is looking very weird. It's hard to tell where the coordinates are. But as long as you have that first coordinate, the starting value, and the next coordinate over, you can figure out the equation. Okay, next up is going to be, and finally it's going to be our exponential equation of a curve through the coordinates -1, 375 and 2, 3. So you notice this is going to be, the last one was exponential growth. This one was growth because it's increasing. This one is going to be decay because the numbers are going down. So you can guess and check until you get your answer. You can see maybe perhaps multiplying by 1/2, multiplying by 0.25. The most common numbers, you can multiply by those to see if it works. But we're going to need to multiply not only once, twice, but 3 times to get all the way back to 3, all the way down to 3. So let's just test some numbers. 375 times 0.5 times 0.5, it's 2, times 0.5, that's 3. Now the number needs to be much smaller. So try multiplying by 0.25. Okay, 93. Multiply by 0.25. 23.4. and multiplying one more time by 0.25 to see if we get there. Look how close that is. It's very close. It's not quite down to 3, but we need to multiply something smaller. So you could try maybe perhaps 0.1 or 0.2, but we're going to use formulas for this. Let's try it out. Our goal is to get to 3. We need to multiply 375 by our multiplier, b. How many steps? All right, this last one, the difference between these ones was only, well, let me highlight it. The difference was only 2 steps. All right, 1, 2. Here, the difference is 1, 2, 3 steps. So I'm going to write that down. It's going to be 3 steps to get to our answer. So instead of bringing it to the second power, we're going to need to write it to the third power, because it's going to take not only 1, 2, but 3 steps. Essentially, we're multiplying 375 by something 3 times to get to 3. It wasn't 0.5, it wasn't 0.25. We can try to solve this. It's going to be a little tough, a little weird, but we're going to solve it right now. So divide both sides by 375. That gives us, let's see, 3 divided by 375 gives us 0.008. Now we need to get rid of the 3, the third power. What's the opposite of the third power? It's going to be the cube root. So if we cube root both sides, that's going to give us our multiplier. What is the cube root? Let's see. Cube root. So math, cube root of 0.008. Let's see what it is. There it is. The multiplier b happens to be 0.2. So if you were able to guess and check 0.2 by taking 3 steps to get there, that's wonderful. Otherwise, you can use a formula like this to tell you what the number is that you need to multiply by 3 times. So that's why we took the cube root. So let's just test it, make sure it works out. So 375 times 0.2 is 75. 75 times 0.2 is 15. And 15 times 0.2 is 3. That checks out. So we're going to need to write our equation now. There's only 2 things we need. We need our starting value, which is 75. And that's our a value. And we also need our b value. Our b value happens to be 0.2. And that will be to the power of x. So there's 2 ways to write this. The first way is to write 75 times 0.2. You could have also said, oh, look, I know I need to start with 75, but I also need to multiply by 1/5. Either of these 2 answers are the same. Why? What is 1/5? 1/5 is 0.2. So either of these 2 answers is correct. And we're done.